And now in this lecture we'll find out the radius of a circle. In the drawing we have quadrilateral ABCD that is described by this circle. AB equals to AD equals to 4, BC equals to 8, BC equals to 6, DC equals to 8, and our task is to find out the radius of this circle that blocks quadrilateral ABCD. So first of all, we'll join points B and D together by a straight line. By joining points B and D, we divide the big quadrilateral ABCD into two triangles. Those are the two triangles. The upper triangle is triangle ABD and the lower triangle is triangle BCD. So we will implement the law of cosines on both triangles. So quickly on the law of cosines. The law of cosines is true in any triangle. This is a triangle ABC that could be in any triangle. Angle BAC equals to theta, AB equals to any sinus left, AC equals to B sinus left, BC equals to C sinus left. So this triangle ABC that could be any triangle, the following equation is true. C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So we implement the law of cosines on both those two triangles. So first of all, we define this angle BCD as theta. Here we will implement Rule 70 in our drawing. Please click on Rule 70. According to Rule 70, in a cyclic quadrilateral, the sum of the opposite angles is equal to 180 degrees. So in the drawing, we have quadrilateral ABCD that is described by this circle. According to this Rule 70, the sum of those two opposite angles is equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. Likewise, the sum of those two opposite angles is also equal to 180 degrees. That is to say, gamma plus delta also equals to 180 degrees. Because of the fact that this quadrilateral ABCD is described by this circle, the sum of its opposite angles is equal to 180 degrees. So you can implement Rule 70 in our drawing. When we put in our drawing, this is quadrilateral ABCD that is described by this circle. And therefore, the sum of those two opposite angles must be equal to 180 degrees according to Rule 70. Therefore, this angle equals to theta, and therefore this missing angle must be equal to 180 degrees minus theta. When we put 180 degrees minus theta plus theta is equal to 180 degrees, that is the sum of the angles of those two. That is the sum of the angles in any cyclic quadrilateral. The sum of those two opposite angles is equal to 180 degrees. Therefore, this missing angle is equal to 180 degrees minus theta. So, first of all, we will implement the law of cosines in this ampere green triangle ABD. We choose angle theta, and this angle BAD This is equal to 180 degrees plus theta. Angle theta from the original law, the law of sines, the law of cosines. We're talking about this angle theta. So in our triangle A, the green triangle ABD, this is angle theta. So we implement the law of cosines in this green triangle ABD. According to the law of cosines, the green triangle ABD, the following equation is true. BD square equals to AB square plus AD square minus 2 times AB times AD times cosine 180 degrees minus theta. And again, this green triangle ABD, according to the law of cosines, the following equation is true. BD square equals to AB square BD square equals to AB square plus AD square minus 2 times AB times AD times cosine 180 degrees minus theta. We have the trigonometric identity that says that cosine 180 degrees minus theta equals to minus cosine theta. So instead of cosine 180 degrees minus theta by minus cosine theta. And we get that BD square equals to AB square. AB is 4, therefore AB square is 4 squared, that is 16. Plus AD square. AD is also 4, therefore AD square is also 16. Minus 2 times AB is 4, times AD is also 4, times cosine 180 degrees minus theta. Cosine 180 degrees minus theta equals to minus cosine theta. So it is minus cosine theta. So minus times minus is plus. So the negative sign turns to a positive. So it's plus. So in total we found out that according to equation 1, BD square equals to 16 plus 16 is 32 minus 2 times 4 times 4 is also, it is plus 2 times 4 times 4 is plus 32 times cosine theta. And again, in total according to equation 1, if you found out that BD square equals to 32 plus 32 times cosine theta. Likewise, we implement the law of cosines on this lower triangle BDC. So according to the law of cosines, this lower triangle BDC, BD square equals to BC square plus DC square minus 2 times BC times DC times cosine theta. But again, according to the law of cosines, in this lower triangle BDC, the following equation is true. BD square equals to BC square plus DC square minus 2 times BC times DC times cosine theta. So we have two different equations, those two different equations for BD square. Therefore, we get equation 3 that says that BD square according to equation 1 must be equal to BD square according to equation 2. So BD square according to equation 1 is equal to 32 plus 32 times cosine theta. And it must be equal to BD square according to equation 2. BD square according to equation 2 equals to BC square. BC is 6, therefore BC square is 6 squared, that is 36. Plus DC square. DC is 8, therefore DC square is 8 squared, that is 64. Minus 2 times BC is 6 times DC is 8 times cosine theta. And again, in total, we found out that 32 plus 32 times cosine theta equals to 36 plus 64 minus 2 times 6 times 8 times cosine theta. So in this side of the equation 3, we have 32 plus 32 times cosine theta equals to 36 plus 64 is 100 minus 2 times 6 times 8, 6 times 8 is 48, and 48 times 2 is 96. So in total, this expression equals to minus 96 times cosine alpha. Minus 96 times cosine theta. So in total, we found out that according to equation 3, (32 plus 32 times cosine theta equals to 100 minus 96 times cosine theta. So here we subtract 32 from this equation. So here 32 will get cancelled. Left only with 32 times cosine theta equals to 100 minus 32 is 68 minus 96 times cosine theta. So you add 96 cosine theta to this equation. So here 96 cosine theta will get cancelled. Well, here on the other side of the equation we have 32 times cosine theta plus 96. Cosine theta equals to 128 cosine times cosine theta equals to 68. Here we have to leave 68. So here we divide this equation by 128. We get that cosine theta equals to 68 over 128. Here we divide both the numerator and the denominator of this number by 2. 68 over 2 is 34 over 128 over 2 is 64. So here we divide both the numerator and the denominator of this number by 2. 34 over 2 is 17 over 64 over 8 is 32. So we found that cosine theta equals to 17 over 32. Those two sides of the equation are equal to each other. Writing down. Cosine theta equals to 17 over 32. We have the following trigonometric identity that says that sinus squared theta plus cosine squared theta equals to 1. Here we subtract cosine squared theta from this trigonometric identity. We get the sinus squared theta equals to 1 minus cosine squared theta. Here we take a look at all of this equation. So we get that sinus theta equals to the square root of 1 minus cosine squared theta. So the next step we substitute cosine squared theta. This equation by cosine squared theta from here. So here, if cosine theta equals to 17 over 33, 17 over 32, it means that cosine squared theta must be equal to 17 over 32 squared. And 17 over 32 squared equals to 0.2822 0.2822. So substitute cosine squared theta this trigonometric identity by 0.2822. You get that sinus theta equals to the square root of 1 and cosine squared theta equals to 0.2822. And 1 minus 0.822 is equal to 0.7177. So today we found out that sinus theta equals to the square root of 0.71777. And the square root of 0.71777 is equal to 0.4717. So to the found out that sinus theta equals to 0.847. But again, we found out that sinus theta equals to 0.847. What is the value of BD? What is the value of BD? we found out that BD squared equals to 32 plus 32 times cosine theta. So now, according to equation, BD squared equals to 32 plus 32 times cosine theta. So according to equation 1, we found out that BD squared equals to 32 plus 32 times cosine theta. But we already found out that cosine theta equals to 17 over 32. So we can substitute cosine theta in this equation by 17 over 32. We do it now and we get that in total BD squared equals to 32 plus 32 times cosine theta. Cosine theta equals to 17 over 32. We have 32 in the numerator, 32 in the denominator, so 32 will get cancelled, and we left only with 17. So total we found out that according to equation 1, BD squared equals to 32 plus 17 is 49. So 32 equals to 49. Here we take root out of this equation. We get that BD equals to the square root of 49, that is 7. BD equals to 7 units in itself. BD equals to 7 units in itself. BD equals to 7 and sinus theta equals to 0.847. So in the next step, we will implement the law of sines in this lower triangle BDC. And again, we will implement the law of sines in this triangle BDC. So if we click on the law of sines, the law of sines is true in any triangle. This is the triangle ABC that could be any triangle. Triangle ABC is described by this circle. And the radius of this circle that blocks triangle ABC is R. AB equals to C units in itself, AC equals to B units in itself, BC equals to A units in itself. This is angle BAC that equals to capital A degree inside. This is angle ACB that equals to capital C degree inside. This is angle ABC that equals to capital B degree inside. So this triangle ABC that could be any triangle. The following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C. Repeat again. A over sinus A equals to B over sinus B equals to C over sinus C. And it is also equals to 2R. And 2R is the radius of this circle that blocks triangle ABC. So we can implement the law of sines in our drawing. And again, we implement the law of sines. This lower triangle BDC. This lower triangle BDC, according to the law of sines, BD over sinus theta equals to 2R. What is the law of sines? Sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So in triangle ABC, this triangle BDC, BD over sinus theta equals to 2R, and R is the radius of this circle. That blocks triangle ABC. That is the radius that we are looking for in this question. So according to the law of sides in triangle BDC, the lower triangle BDC, BD of sinus theta equals to 2R. BD is 7. Or sinus theta equals to 0.847 equals to 2R. 7 over 0.847 is equal to 8.2644 and it equals to 2R. Here we divide this equation by 2. We get the radius that we are looking for in this question. The radius R equals to 4.132 units in itself. We should find out that the radius of this circle, that is the radius that we are looking for in this question, is equal to 4.132 units in itself. So we finish with the question in the next step and some of the lecture. One task in this question is to find out the radius of this circle. So this circle blocks quadrilateral ABCD, or quadrilateral ABCD is inscribed by this circle. We know that AD equals to AB equals to 4, BC equals to 6, CD equals to 8. Again, our task is to find out the radius of this circle that blocks quadrilateral ABCD. So first of all, we join points B and D together by a straight line. By joining points B and D, we divided this quadrilateral into two triangles. The first triangle is the green triangle BD, and the second triangle is the lower triangle, triangle BDC. So in the next step, implemented the law of cosine on each of those triangles. But first of all, we define angle BCD as theta, and therefore the opposite angle must be equal to 180 degrees minus theta. Why put 180 degrees minus theta plus theta equals to 180 degrees? That is the sum of the opposite angles in any cyclic quadrilateral, according to rule 70. And again, according to rule 7, the sum of the opposite sides in any cyclic quadrilateral, so the sum of the opposite angles in any cyclic quadrilateral is equal to 180 degrees. Therefore, 180 degrees minus theta plus theta is 180 degrees, exactly according to rule 70. Therefore, this material must be equal to 180 degrees minus theta in its size. So first of all, we implemented the law of cosines. This great triangle, triangle BAD. So please click on the law of cosines. The law of cosines is for an triangle. This is triangle ABC, that could be any triangle. This triangle BAC is equal to theta degrees in size. Side AB equals to units in itself. Side AB equals to A units in itself. Side AC equals to B. Side AC equals to B units in itself. Side BC equals to C units in itself. So this triangle ABC that could be any triangle. The following equation is according to the law of cosines. The following equation is true. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So, implement the law of cosine in this triangle, grand triangle ABD. According to the law of cosines, in this grand triangle ABD, the following equation is 2. BD square equals to AB square plus AD square minus 2 times AB times AD times cosine over integral 1 theta. Again, this BD according to the law of cosines, the following equation is true. BD square equals to AB square plus AD square minus 2 times AB times AD times cosine over integral 1 theta. We have the algebraic, the trigonometric identity that states that cosine over integral 1 theta equals to minus cosine theta. So we can substitute cosine over integral 1 theta by minus cosine theta. We did it, and we found out that BD square equals to AB square. AB is 4, therefore B square is 4 squared, this is 16, plus AD square. AD is also 4, so therefore AD square is 4 squared, this is 16. Minus 2 times AB, that is 4 times AD is also 4 times cosine over integral 1 theta. Cosine over integral 1 theta equals to minus cosine theta. So then we found out that dB square equals to 16 plus 16 plus 2 times 4 times 4 times cosine theta. Why? Because cosine over integral 1 theta is minus cosine theta. And we have minus times 1, so it's plus. So in total we found out that BD square equals to 16 plus 2 times 4 times 4 times cosine theta. So BD square equals to 16 plus 16 is 32 plus 2 times 4 is 8, 8 times 4 is 32. So in total this expression equals to 32 times cosine theta. In total, I found out that according to equation 1, BD square equals to 32 plus 32 times cosine theta. The next step, we implemented the law of cosines in this lower triangle BDC. According to the law of cosines in this green white triangle BDC, the following equation is true. BD square equals to BC square plus DC square minus 2 times BC times BD times cosine theta. Okay, again, this white triangle BDC, according to the law of cosines, the following equation is true. BD square equals to BC square plus DC square minus 2 times BC times DC times cosine theta. So we have BD square, this is equation 2, according to equation 2, BD square equals to BC square BC is 6, therefore BC square is 6 squared, that is 36. And again, BC square is 36 plus DC square. DC is 8, therefore DC square is 8 squared, that is 64. Again, DC square is 64 minus 2 times BC, that is 6, times DC, that is 8, times cosine theta. So we have two different expressions for BD square. This is equation 1 for BD square, this is equation 2 for BD square. Therefore, we get an equation 3 that says that BD square according to equation 1 must be equal to BD square according to equation 2. BD square according to equation 1 equals to 32 plus 32 times cosine theta. And it must be equal to BD square according to equation 2. BD square according to equation 2 equals to 36 plus 64 minus 2 times 6 times 8 times cosine theta. So in total, according to equation 3, I should find out that 32 plus 32 times cosine theta equals to 36 plus 64 minus 2 times 6 times 8 times cosine theta. So we have here equation 3, 32 plus 32 times cosine theta equals to 36 plus 64 is 100, minus 2 times 6 times 8 is minus 96 times cosine theta. So again, according to equation 3 in total, we found out that 32 plus 32 times cosine theta equals to 100 minus 96 cosine theta. So here we subtracted 32 from this equation. Here 32 we get cancelled, left only with 32 times cosine theta. And here we have 100 minus 32 is 68 minus 96 times cosine theta. So here we get 96 cosine theta to this equation. So here this expression will get cancelled, and we have only this out of the equation with 68 equals to 32 times 32 cosine theta plus 96 cosine theta equals to 128 cosine theta. On the other side of the equation we left with 68. So in total we found out that 128 cosine theta equals to 68. Here we divided this equation by 128. And so we found out that cosine theta equals to 68 over 128. Here we divided both numerator and the denominator of this expression by 2. 68 over 2 is 32. 68 over 4 is 34. And 128 over 2 is 64. So total we have here 34 over 64. Here we divided this expression both the numerator and the denominator of this expression by 2. So 34 over 2 is 17, over 64 over 2 is 32. So in total, those two sides of the equation are equal to each other. That is to say, cosine theta equals to 17 over 32. Cosine theta equals to 17 over 32. If cosine theta equals to 17 over 32, it means that cosine squared theta must be equal to 17 over 32 squared. 17 over 32 squared equals to 0.2822. And again, cosine squared theta equals to 0.2822. We have the trigonometric identity that says that sin squared theta plus cosine squared theta equals to 1. It is very easy to prove that this trigonometric identity is true, but we will not do it in this lecture. So sin squared theta plus cosine squared theta equals to 1. Here we subtracted cosine squared theta from this equation, and we found out that sin squared theta equals to 1 minus cosine squared theta. Here we took out of this equation, and we found out that sin theta equals to the square root of 1 minus cosine squared theta. So we can substitute cosine squared theta in this trigonometric identity by 0.2822. Cosine squared theta equals to 0.2822. We did it, and we found out that sin theta equals to 1, square root of 1, and cosine squared theta is 0.2822. 1 minus 0.2822 is 0.7177. So inside of the root, we left only with 0.7177. The square root of 0.7177 is equal to 0.847. So in total, we found out that sin theta equals to 0.847. According to equation 1, we already found out that BD squared equals to 32 plus 32 times cosine theta. So BD squared equals to 32 plus 32. Cosine theta is 17 over 32. So cosine theta is 17 over 32. We have 32 in the numerator, 32 in the denominator, so 32 will get cancelled. And left here, only with 17. So 32 plus 17 is 49. So in total, we found out that BD squared equals to 49. Here we took out all this equation, and we found out that BD equals to the square root of 49, that is 7. And again, in total, we found out that BD equals to 7 units in itself, and we only found out that sin theta equals to 0.847. The next step, we implemented the law of sines. This lower right angle BDC. So piece of paper on the law of sines. This is triangle ABC that could be an triangle. Triangle ABC is described by this circle. AB equals to 3 units in its length, AC equals to 1 unit in its length, BC equals to 1 unit in its length. This is angle BAC This is equals to capital A decreasing in size. This is again ACB. This is equals to capital C decreasing in size. This is again ABC. This is equals to capital B decreasing in size. So in this triangle ABC that could be any triangle, the following equation is true. A over sin of A equals to B over sin of B equals to C over sin of C equals to 2R. And R is the radius of this circle that flows triangle ABC. And again, according to the law of science, this triangle ABC that could be any triangle, the following equation is true. A over sin of A equals to B over sin of B equals to C over sin of C equals to 2R. And R is the radius of this circle that blocks triangle ABC. So we can definitely implement the law of science in our drawing, right? In our drawing, if you focus at this is triangle BCD, that is definitely inscribed by this circle. Why this triangle BC is inscribed? Why this triangle BCD is inscribed by this circle? Because of the fact that all the three vertices of triangle BCD lie on the circle. Therefore, we can implement here the law of science. According to the law of science, in this triangle BC, the following equation is true. BD over sin of theta equals to 2R. Again, BD over sin of theta equals to 2R, and R is the radius of this circle that blocks triangle ABC. It is also the radius that we are looking for in this question. So we can found out that according to the law of science, this lower right triangle BDC, the following equation is true. BD over sin of theta equals to 2R. BD is 7, sin of theta is 0.847 equals to 2R. 7 over 0.847 is equal to 8.2644 equals to 2R. Here we divided this equation by 2 and found out that the radius that we are looking for in this question, that is the radius of this circle, is equal to 4.132 inches length. Okay, again, the radius of this circle is equal to 4.132 units in its length. Okay, thank you very much.